let's start the class. In the last class, this theorem about invariants. The first proof, this four portion of this theorem, this first four part of this theorems were proved. Let me recap it once again, just a small review, you can say, that says that if we have this kind of general expression of second degree in two variables x and y, and after rotation, if this expression is converted into this kind of expression, then we can prove that all these five quantities are invariant. Invariant in this, it means that a plus b should be is equal is it's an invariant means a plus b should be is equal to a prime plus b prime. Okay, that means the coefficient of x square plus coefficient of y square is always a constant quantity. It does not change. The numerical value of this quantity does not change after rotation. The individual expressions, the value of a prime and the value of b prime may individually change, but their summation would always be same. So a plus b should be is equal to a prime plus b prime. Similarly, g square plus h square, that should be is equal to g prime square plus h prime square, and so on, etc., and all the other results. We proved these four results in the last class, and during that time what we did, that if this is the given expression and this equation number 2, if it represents the transformation formula, we know that this is the general form of the rotation can be written in this way. And whenever we put this equation number 3 in equation number 1, as per the result, we would get this equation number 2. So we are putting this equation number 3 in equation number 1, and we ultimately get this kind of large expression, and that has to be same as this kind of expression, and therefore we compare the similar expressions. That means the coefficient of x square along with the coefficient of x square from this expression. Similarly, the coefficient of xy along with the coefficient of xy from this expression, and so on. Okay. And finally, we got this kind of transformation formula: a prime, b prime, h prime, g prime, a prime, c prime can be written in this way. And by the help of these results, we proved the results that a prime plus b prime, that becomes is equal to a plus b. Similarly, a prime b prime minus h prime square becomes is equal to ab minus h square. G prime square a prime square is equal to this g square plus f square. And finally, we prove this result that b prime c prime plus c prime a prime plus a prime b prime minus a prime square minus g prime square minus h prime square becomes is equal to bc plus ca plus ab minus f square minus g square minus h square. So that was the last result we proved in our previous class. And during the proof, we had to consider the expression of four new quantities. Most of them, mainly the two new quantities that we need to remember is the quantity, the expression of a1 and b1. a1 is equal to a cos theta plus h sin theta, and b1 is equal to h cos theta plus b sin theta. And if we differentiate this a1 with respect to theta, we get the expression of a2. Similarly, if we differentiate the expression of b1 with respect to theta, we get the expression of b2. And assuming all these four results, we are able to write a prime in this way, b prime in this kind of expression, and h prime has two different expressions. This is the first expression containing the quantities having index 2, and the second is the expression containing the quantities having index 1. So h prime has two different expressions. We discussed the detailed computation of all these results, so I am not going through the detailed computations over here. Rather, I have to use these results, okay, in order to prove the last part. So let me directly go to the proof without wasting time. And for that, I need to split the screen a bit. Okay. Okay, fine. Now let's move. We have to consider these four quantities A1, B1, and A2, B2, and finally we had this kind of results. So I am not going to prove all these results because that the computation has already been shown previously. Hmm. So let me start this last part. That means delta prime must be is equal to this quantity delta, and the book I advised you, the book of Hoshan Chakraborty. The book in this book you wouldn't find the proof of this part. Okay, so over here we are starting with this delta prime. Delta prime is equal to this kind of determinant, and we are expanding this determinant with respect to the third row. Generally, when we expand with respect to these different rows and columns, we try to uh, count the positive and negative signs. We generally count in this way. Alternatively, that means this should be plus, then minus, and this should be plus. So, if we want to expand the determinant with respect to the third row, then G prime along with the corresponding cofactor would have the positive sign. So this would be the cofactor containing these four elements H, G prime, H prime, G prime, and B prime, A prime. So this is the cofactor of G prime. Next, if this is plus, then the next term would have the minus sign. So A prime into corresponding this determinant plus after minus sign we will have another plus sign. So C prime into the corresponding cofactor. Got it? So in this way, we can expand the determinant delta prime. And now, what we are going to do over here is that consider this first determinant. In this first determinant, we already have the expressions of A prime, B prime, H prime, and along with that, we have the expressions of over here G prime and A prime. Hmm. So over here, H prime is there. We have a confusion regarding the expression of H prime because H prime has two different expressions. One having index suffix 1, another is the having suffix 2. So which expression should we use in place of H prime? That we should determine. How to determine it? So let us first put the expression of G prime, B prime, and A prime in this determinant. This is the expression of G prime. This is the expression of G prime. Next, A prime has this kind of expression minus G sine theta plus F cos theta. And what about B prime? We already have the expression of B prime. This is the expression of B prime. B prime is equal to minus A2 sine theta plus B2 cos theta. So we already have the expression of this B prime. This much is okay. Now, what we observe is that in this first column, in this second column, this column we do not have anything with index 1 or 2, and over here we have an expression having index 2, and that's why in order to match with this expression we are choosing the expression of H prime having the index 2, this expression, not this second one. Got it? In order to match over here, we are putting the expression, this first expression of H prime containing this index 2. So we are putting the expression of H prime over here. Is it clear to you, everybody? সবার কাছে কি ব্যাপারটা clear?
Yes, sir.
Okay.
Yes, sir.
Okay, so let's continue. So in this way, you have to eliminate your confusion. Got it? You have to be you have to have certain hint, and that hint comes from this second part, because this second part is about the expression with suffix to. So now, fine, let's move to the next term. In the next term, we again have the expressions of a prime, g prime, f prime, and h prime. Hmm. So over here we are firstly putting a prime and this g prime, and then a prime. Let us put their expressions. So this is the expression of a prime, this is the expression of g prime, and this is the expression of a prime. No confusion is there so far. Now over here we find that we have the expression containing the index 1, and therefore we choose the expression of h prime over here with index 1. Got it? And therefore we put this expression minus a1 sine theta plus b cos theta in this position of h prime in order to match with this first term over here. And the last this last determinant, we are just expanding this last determinant because we don't need to prove anything else about this determinant. This determinant can be written as a prime b prime minus h prime square. Keep it fixed, don't touch this one. Hmm. Now we make our manipulation for the first determinant and for the second determinant. We are going to express this first determinant. What we are doing, we are first taking the transpose of this first determinant. Over here, these rows and columns are interchanged. We are taking the transpose. That's why this first column with index 2 now becomes the first row with index 2, and this second column now becomes the second row. Okay. And similarly, we are considering the transpose of this second determinant as well. This first column now becomes the first row over here, and this second column, now this second column becomes is equal to the second row. Got it? Fine. Now we are trying to express this first determinant as the product of two determinants. You see, if you consider the row into row multiplication, because determinant multiplication can be done by row into row, then row into column, then column into row, and column in column. So all kind of multiplication is valid in case of determinant. Hmm. Now over here a2 b2 is this row, so a2 multiplied by cos theta plus b2 multiplied by sine theta would give us this expression. Okay. Next, this a2 multiplied by this minus sine theta, then b2 multiplied by this cos theta would give us this kind of expression. Similarly, f into cos theta plus g into cos theta plus f into this sine theta would give us this expression. And finally g into minus sine theta plus f into cos theta would give us this kind of minus g sine theta plus f cos theta, this kind of expression. So what we observe is that this determinant, the coefficient of g prime, the determinant can be written as the product of two determinants. And similarly, if you consider the this second expression over here, this can also be written as the product of these two determinants. One is this determinant and another is this kind of determinant. You can match this one, a1 cos theta, a1 into cos theta plus b1 into sine theta would give us this kind of expression, and so on. I'm not going to in the detail of this multiplication. Okay. So what we observe is that this determinant of this expression, this second determinant, that what would be the expansion? Cos theta into cos theta. That means cos square theta minus this plus sign. So plus sine theta into one more sine theta. It would give us sine square theta. So cos square theta plus sine square theta is equal to 1. So the value of this total determinant becomes is equal to 1. So multiplication by 1 would give us the same expression. Hmm. So in the next line, what we are doing in the next line, we are just writing simply g prime into this kind of determinant a2, b2 to g and f. And in the second line, what we are writing, this we are just keeping the first determinant, and the value of the second determinant is simply is equal to 1. And what about the last term? In this last term, we already have the result that c prime is equal to c. This c prime is equal to c. So in place of c prime, we can, in place of this c prime, we can put c, and we already proved that a prime b prime minus h prime square is equal to ab minus h square in the previous question. So we can directly use these two results. Got it? So ultimately, we have this kind of expression, and now expand this determinant. We expand this determinant. Got it? Hmm. And this next line would be, next two lines would be the key factor of this proof. এই প্রুফের নেক্সট দুটো লাইন কিন্তু খুব ইম্পর্টেন্ট, একটু কেয়ারফুলি দেখো। How to manage? Over here we're just expanding, that would be a2 into f minus b2 into g. So that is the expression. Similarly, the coefficient of f prime would be a2 a1, this a1 into f plus b1 into g. So we have this kind of expression. Fine. Now what we are doing over here, we are in this expression, from this expression we are trying to extract the coefficient of g, not g prime. Okay, we are trying to extract the coefficient of g and the coefficient of f. We are trying to convert the entire expression in terms of f, g and c. And that's why over here in place of g prime, we are just trying to extract the coefficient of g. How to extract the coefficient of g? You see, we would have a term minus b2 into g prime. So if this g is taken common, then we would simply have minus b2 g prime. Similarly, this minus sign and this minus sign, they would constitute the plus sign together. So plus b1 into a prime would be there, multiplied by g. So if we take this g common, we would have b1 into a prime. So from these two terms, we can get the contribution of g, the coefficient of g. Now similarly, we can extract the coefficient of this minus f. We are just keeping the same kind of positive and negative order. The first one is positive, second one should be negative, the third one is positive. We are not changing the last expression at all. So everything should be done in these two first expression. Got it? So we can now similarly over here extract the coefficient of minus f over here. How to extract? You see, from this expression a1 into minus f prime would give us simply a1 f prime with this negative sign written previously, and over here a2 in g prime into f, they would together give us this minus a2 g prime. Along with this minus sign, it would be a plus quantity. So we have this kind of expression. Now this coefficient is again converted in terms of a determinant. It would be b1 b2 into g prime f prime, and this expression is again converted into this kind of determinant a1 a2 into g prime and f prime. Now we put again the expressions of b1 b2 a1 a2 g prime and f prime. What is the expression of b1 b2? we already have these expressions b1 and b2. Hmm. So we are putting these expressions of b1, b2 over here, b1, b2, g prime, f prime. This would give us this kind of determinant. And similarly, if we put the expressions of a1, a2, g prime, f prime, we would have this second kind of determinant. And again, we can rewrite these two determinants as the product of two determinants. Over here, you see, if we consider a determinant h into b and g f, h b g f, this kind of determinant, if we multiply it by this the same kind of determinant as I discussed earlier, that h into cos theta plus b into sin theta, row into row multiplication, h into cos theta plus b into sin theta. This would give us h cos theta plus b sin theta. Hmm. Now we have again this first row multiplied by, sorry, this first row multiplied by this second row. So we would have h into minus sine theta, that means minus h sine theta plus b into cos theta, so plus b cos theta. So in this way we can express all the terms in the determinant, all the terms of the determinant as the product of these two determinants. And similarly, this second determinant can also be written as the product of two determinants. One is the determinant having terms a, h, g, and f, and the second one is cos theta sin theta minus cos theta sin theta. Got it? Now, Now, if we expand this determinant, its value would be the value of this determinant is equal to 1. So we can remove it just as a multiplier factor, multiplication factor. And the second one is the same determinant having value of equal to 1. So we can neglect them. And finally, what we have, g into h, b, gf, the determinant, minus f into ahgf plus c into this last expression ab minus h square can now be written as the determinant ahhb, this kind of expression. So finally, if we, because of the presence of this plus and minus sign in different orders, in alternative orders, therefore we can now write this total expression as the determinant AHG, HBF, GFC, and that is nothing but is equal to delta. So in this way, we can now prove that we started with our determinant delta prime, and this delta prime becomes is equal to the determinant delta. So this completes the proof of the last part. Got it? Now, do you have any question over here? Is it clear?
Yes, sir.
Okay. And any others? Is it clear to you, everybody? Hopefully clear. If you have any further
Yes,
doubt.
sir.
Okay, thank you. Hopefully clear. Although you can watch it later in the YouTube video. I would post it in YouTube after completing this lecture. Hmm. Now, I am keeping similar result for your homework. Okay, this theorem. I am leaving this one for you. In this case, we are just considering the translation only, not the rotation. That means the transformation formula that you did in case of class 11 and 12 probably. X prime is equal to x minus alpha, or y prime is equal to y minus beta. This kind of transformation. Hmm. So under this kind of transformation, you will have to prove that all these four quantities are invariant. That means A would be is equal to A prime, H would be is equal to H prime, B would be is equal to this B prime, and delta would be is equal to delta prime. You got my point? ব্যাপারটা বোঝা গেল? Hmm?
Yes, sir.
Okay. Okay, so
হ্যাঁ
what?
স্যার বুঝলাম।
আচ্ছা ঠিক আছে, so one observation over here I would like to share with that. This firstly, this determinant delta. This determinant delta is independent of translation and rotation. It does not change. The value of this expression does not change under translation and rotation. If you consider the individual transformation formula, one is translation, another is rotation. This quantity delta, it does not change under translation and rotation. That is one observation. So if you consider the general kind of expression that I discussed earlier in probably in previous part, some kind of expression was there. Yes, this kind of orthogonal transformation. Over here, this is the transformation where we together consider the translation and rotation formula. So even if you consider this kind of formula, the expression of the quantity delta, that does not change. That is one observation. Hmm. And the second observation is that under translation only, this coefficient of second degree term, a prime or a, whatever you call, Hmm. That would be the coefficient of second degree term. Under translation only, the coefficient of second degree term, that means A, H and B. All these quantities, they do not change at all. That is a very good observation, and we shall use it in our subsequent problems. Got it? So if we simply consider the translation formula, the if the translation formula does not going to affect this second degree term. The translation formula would only affect the first degree term only. Got it? Hmm. The translation formula would have any effect on this first degree term only, and maybe on constant term. But the translation formula does not have any effect on this second degree term. And similarly, in case of rotation, that means in case of previous theorem, we had a result that C prime is equal to C, isn't it? So, in case of rotation, the constant term does not change at all. That these two observations would be very useful in the second chapter, the general equation of second degree. Hmm. So this is the point that I was trying to highlight in today's lecture. And keeping these 2 points in our mind, let us try to discuss one or two problems from your book. This is the oh before that I got one question in your book that it says that show that this determinant some this is actually called the discriminant of this kind of expression, general expression of second degree. Okay, so forget about the nomenclature. I can simply say over here you have to show that this determinant hmm, is invariant under translation and rotation. So hopefully now you can prove this result. Hmm. I am keeping one part as a homework regarding the translation, but in case of rotation, I have already proved this result. Hmm. And this file is already available in your this Google Classroom section under this topic transformation of coordinates. So hopefully you got this PDF file. Hmm. Now, one more observation that I need to share with you, that that one question is there. Where is the question? The determinant x1 y1 1 x2 y2 1. Where is the question? Yeah, this is the question. Hmm. It says that under rigid body motion means under the transformation for this first theorem, we proved that under rigid body motion, That means under this kind of transformation of orthogonal transformation, the distance between 2 points does not change. We prove this result. So with the help of this kind of transformation formula, we will have to prove that this kind of determinant, you already have the expression of x1, y1, x2, y2, x3, y3. We have three different points, a1, a2, a3. Together, it is written as ai. Okay, so we have three different points. Let me write the picture if possible. Just a minute, because some geometry is there related with this problem. Hmm. So let me write these 3 points. This is one point. This is another point, and this is the third point. Suppose the point becomes very bad. Anyway, these are the points. Okay. Suppose this is the first point A1. This is the second point A2, and this is the third point A3. And now if we join A1, A2 and A3, you will get a triangle. So you will get it is becoming very bad triangle anyway. Hopefully it is understandable to you. So suppose this x1 has the coordinates, this kind of coordinates. This point a1 has the coordinates x1, comma y1. And similarly, the second point a2 has the coordinates x2, y2. The third point a3 has the coordinates x3, y3. And we have a formula. Probably you have gone through this kind of formula for finding the area of this triangle. The formula is actually the half of this determinant. Can you remember? এটা কি মনে আছে? Half of this determinant. এই determinantটাকে expand this, you will get the area of the triangle. এটা কি তোমাদের কাছে ছিল? আগে পেয়েছো? Did you got this result earlier?
হ্যাঁ স্যার 12 এ ছিল।
Okay.
হ্যাঁ স্যার ছিল, কিন্তু স্যার ভুলে গেছি।
Anyway, let's recall it.
ছিল স্যার,
ভুলে গেছো কোনো ব্যাপার নয়, এখন মোটামুটি রিকল করে নিতে পারছো। So that means you will have to prove that if we divide it by half, if this expression remains invariant quantity under rigid body transformation, I am keeping this one as a homework for you. If this expression remains invariant under rigid body transformation, that means under translation and rotation, if we divide it by half, the corresponding expression would also be an invariant quantity. Okay, that means the area of a triangle having the vertices a1, a2 and a3, that area would be an invariant quantity that we expected in the proof from the first proof. I told you earlier that as a consequence of the result of the first proof, the first result says that the distance between 2 points, any 2 points, does not change under orthogonal transformation. Got it? And therefore, as a result, if the distance between a1, a2 and a2, a3 and a1, a3, if the distance does not change in between these 3 points, then the corresponding area of the triangle formed by a1, a2, a3, this should not be changed. That was a guess, or we can say a presumption. But currently we are going to deal with the proof of the result. Then that would be the proof. If you can prove that this determinant remains invariant, then the half of the determinant would also be remain invariant. So this question can also be selected in this way, that show that the area of a triangle does not change under rigid body motion. এটা এইভাবেও দেওয়া যেতে পারে। ব্যাপারটা ক্লিয়ার হলো?
Yes sir.
Okay. So let's continue with another question. the question that is discussed in the solved problem in this book. The solved problem in this book probably this question, right? This question number 4. It says that to what point the origin is to be moved so that one can get rid of the first degree terms from the equation. That means we have to apply the transformation formula. Origin is to be moved. Suppose the origin is moved to the point alpha comma beta, then we will have this kind of transformation formula: x is equal to x prime plus alpha, y is equal to y prime plus beta. Let me make it a bit larger. So we have this kind of transformation formula: x is equal to x prime plus alpha, y is equal to y prime plus beta. Now it says that we have to move the origin in such a manner that after transformation formula, the corresponding first degree term means the term containing x. This expression, the first degree term, the term containing x and the term containing y, these two are the first degree terms. The corresponding first degree terms would be removed from the final expression. Got it? So what we are doing, we are substituting this transformation formula: x is equal to x prime plus alpha, y is equal to y prime plus beta in this given equation. We are substituting the transformation formula in this given equation, and in that case we will get this kind of expression. Got it? Now you don't need to expand the entire expression. Just what you need to do, you need to identify the coefficient of first degree term. That means the coefficient of x prime and the coefficient of y prime. How to identify it? Over here, from this first term, we can have the coefficient of x prime twice x prime alpha. That would be the coefficient twice x prime alpha. So if you consider the coefficient of x, we will have the contribution twice alpha from this term. Okay. Next, from this term, we will have x prime multiplied by beta. Okay. So x prime beta over here, the coefficient of x prime would be this expression beta only. Okay. And from the third term, no x prime would come because it is about y prime plus beta whole square. So forget it. Now from this fourth term, minus 7x prime is there. So as a coefficient, this minus 7 should come. So this would construct the coefficient of x prime, and in the remaining portion, no expression is there regarding x prime. So in this way, you can identify the coefficient of x prime. Got it? And similarly, the coefficient of y prime. From this first term, we would not have any contribution as far as y prime is concerned. Now y prime, how to obtain y prime? This alpha into y prime would give us a term containing one y prime. So this alpha would be the coefficient of y prime over here. Next, 2 into twice beta y prime. That would give us another y prime. So 2 into twice beta, that means 4 beta would come as the coefficient of y prime. And from this portion, no contribution would come about y prime, so forget it. And from this portion, minus 5 y prime would come. So this minus 5 is the coefficient of y prime, and the remaining portion is about the constant terms, minus 12 plus 12, so forget it. So these two would be, this is the coefficient of x prime, and this would be the coefficient of y prime. And as per the question, these two expressions should vanish separately, individually. These two expressions should vanish. In that case, the term containing x prime and the term containing y prime will be removed. Got it? And therefore, we put this expression is equal to 0, and this expression is equal to 0. Now the question is that whether this kind of assignment is valid or not. A validity question should come. The answer may be given in this way that if we are to find the value of alpha and beta, two unknown quantities are there. And that's why we can construct two independent equations. This is one equation and this is another equation. Got it? So if we can find two such values, one is the value of alpha and another is the value of beta, satisfying these two conditions, then we can say that yes, the assignment is a valid assignment. And if it is not possible to find this kind of values of alpha and beta, then we would say that the assignment is incorrect. And in that case, the only conclusion would be that the coefficients of x prime and y prime cannot be simultaneously be equal to 0. Together we cannot remove the x coefficient, the x prime and y prime related terms. That would be the conclusion. But over here we are lucky that we only have two unknown quantities alpha and beta, and that can be obtained by solving these two equations. So we are solving these equations and we ultimately get the values of alpha and beta. Alpha is equal to 3 and 2 by 7, and beta is equal to 3 by 7. So this would be the corresponding result. Got it? So in this way we can remove the first degree term by applying the translation. And one remark is there: to remove the linear terms. Linear terms means first degree terms. The origin is to be shifted. In your exercise you will get this kind of questions. In this question you are directly given the information that origin is to be moved. তোমাদের এই ইনফরমেশনটা প্রোভাইড করা আছে। Origin is to be moved, but sometimes in the question no such information is there. Just in the question says that find the transformation. It may be translation, it may be rotation. Okay, find the transformation so that the coefficient of x and the coefficient of y, or the coefficient of first degree term gets removed. So in that case you will be in confusion what to do. The confusion can be removed by this kind of remark or note. It says that in order to remove the linear terms, the origin is to be shifted. That means we need to apply the translation formula. Rotation would not vanish our first degree term. Got it? So what is the use of rotation? That is the next question, and that can be answered by another kind of question. This kind of question: if you want to remove some second degree term, like maybe the x square related term or xy related term or y square related term, this kind of terms can be removed by the application of rotation. So let's go through this question. Question number 6. It says that find the angle by which the axis should be rotated so that the equation ax square plus twice hxy plus by square is equal to 0 becomes another equation in which the term xy is absent. This kind of term. Got it? And that can also be written in this way, that find the angle through which the axis to be rotated. Over here it is given that you have to apply rotation, but sometimes in the questions you would not be provided the corresponding transformation formula, whether it is rotation or translation. So you have to apply your common sense. And it says that find the angle through which the axes are to be rotated so that the equation, this kind of equation, is an equation over here, this second degree equation, and only constant term is there. No more first degree term containing x or simply y is there. Anyway, that may be reduced to the form ax square plus by square is equal to 1. That means xy term would be vanished. And we also need to find the values of these two coefficients A and B, these two coefficients A and B. And remember, I told you earlier that under rotation, the constant term C does not change. That means C becomes is equal to C prime. That's why the constant term has not been changed over here. And it is given an extra added information that A should be greater than 0. So in question, this kind of information may be provided, may not be provided. Accordingly, you will have to compute. Okay, so let's try to find out how to find this kind of transformation formula and what would be the corresponding angle of rotation. Let theta be the angle of rotation. Got it? In that case, the transformation formula would be that I considered earlier, that this kind of transformation formula, x is equal to x prime is equal to x is equal to x prime cos theta minus y prime sin theta, y is equal to y prime x prime sin theta plus y prime cos theta. So this kind of formula would ultimately appear. So corresponding expression, this over here, the expression of x and y have been used over here directly. Okay, without showing the transformation formula, they have used the expression, but in exam at least you have to show the transformation formula. Don't skip the steps that has been skipped in your book. Okay, so over here we can put these expressions, and ultimately what you need to do as per the question, you have to identify the coefficient of x prime and y prime. And remember, they have already removed for simplicity the expression of x prime and y prime. Just in place of x prime they have used x, and in place of y prime they have used y, just for the sake of simplicity. But I would suggest you don't work through this kind of technique, because that makes confusion for the teacher who would ultimately check your copy. Got it? In your exam. So make it lucid, don't use this kind of expression. Anyway, so ultimately you would have this kind of expression that a x prime cos theta minus y prime sin theta plus twice h x prime cos theta minus y prime sin theta, and so on. This kind of expressions would be there. So ultimately what you need to do, you need to identify the coefficient of x prime and y prime from this expression. Got it? So what to do? You will get the coefficient of x prime y prime from this term, minus 2xy sin theta cos theta into a. That would give us one coefficient of x prime y prime. What would be the coefficient? The coefficient would be minus actually they have sorry, they have deleted that 2. 2 should come over here, minus 2 should come over here, and another 2 should come over here. Got it? And they have deleted this number 2. Anyway, hopefully it is clear to you. So minus 2 twice a, this is the minus twice a, 2 into minus a sin theta cos theta would ultimately come. So minus twice a sin theta cos theta should come from this first term. And oh, and from this term, okay, plus 2 x into y into sin theta cos theta should come over here. So twice b sin theta cos theta should come from this last term. Got it? And finally, from this term, some contribution of xy should also come. How to find the contribution of xy? You see, this term when multiplied by this term, okay, we will have twice h x y cos theta into cos theta, that means cos square theta, twice h cos square theta into xy. This is twice h cos square theta into xy, the coefficient of xy. Got it? Twice h cos square theta. And similarly, whenever this term would be multiplied by this term, then we will have minus twice h x into y into sine square theta. So minus, this minus sign is there, minus sine square theta into twice h would ultimately come. So in this way, the corresponding coefficient of xy is identified, and that has to be put equal to 0. That's why they have put equal to 0. And finally, they have deleted these two coefficients, this 2 and 2. So these 2 ultimately, these are gone. Okay. So in this way, they have identified the coefficient of xy, and that is put equal to 0. And after manipulation, this sine theta cos theta becomes is equal to half of sine twice theta. That's why they put this half. And this cos square theta minus sine square theta becomes is equal to cos twice theta. So they have put it over here. And finally, from this expression, we can have this expression of tan twice theta, that is equal to twice h by a minus b. Try to remember this expression, because this same expression will come in the next chapter, that is actually the general equation of second degree. Okay. Now 10, if we can from this expression, if we can solve this expression, that means if we can find the value of theta, then it is possible to remove the term containing xy. And in this question, it is given that a is equal to 17, b is equal to minus 7, and twice h is equal to 18. If you compare it with the standard expression, that is a is equal to 17, twice h is equal to 18, so b is equal to minus 7 over here. Got it? Therefore we just put all these expressions. If a is equal to 17, twice h is equal to 18, means h is equal to 9, and b is equal to minus 7. And therefore what would be theta? Theta is equal to half of tan inverse of the right hand side. Over here, if tan twice theta is equal to this twice h by a minus b, then twice theta is equal to tan inverse of the right hand side, and then theta would be is equal to half of tan inverse of the right hand side. So this expression is equal to twice h means 18 divided by a is equal to 17, and minus b means plus 8. So ultimately we have this kind of result, half of tan inverse of 3 by 4. Now one question I would like to ask in this point: can you find the value of theta over here? তোমরা কি থিটার ভ্যালুটা এখান থেকে কোনোভাবে বের করতে পারো? Do you have any standard formula? Please try to answer my question. Can you find the value of theta by any standard formula? Hello? Hello? Are you following?
স্যার ওই tan টু থিটার থেকে কি
এই যে theta is equal to half of tan inverse of 3 by 4. এখান থেকে
tan থিটার ভ্যালু।
হ্যাঁ, থিটার ভ্যালু।
হ্যাঁ স্যার, থিটার ভ্যালু তো বের হয়েছে, থিটা ইকুয়ালস টু হাফ অফ tan ইনভার্স
নিউমেরিক্যাল ভ্যালুটা বের করা যাবে? নিউমেরিক্যাল ভ্যালুটা বের করা যাবে?
হ্যাঁ স্যার, ফর্মুলা প্রয়োগ করলে tan ইনভার্স
কত?
tan ইনভার্স x এর tan ইনভার্স x এর ফর্মুলাটা প্রয়োগ করলে হবে।
তা সেটা কত হবে? এখানে থিটা ইজ ইকুয়াল টু হাউ মাচ?
স্যার tan ইনভার্স x এর ফর্মুলা ছিল হচ্ছে 1/1 প্লাস x স্কয়ার।
ট্যান ইনভার্স এক্স এর কি? এটা ট্যান ইনভার্স এক্স এর ফর্মুলা নাকি 1/1 প্লাস এক্স স্কোয়ার?
নো স্যার, আমি একটু ভুল করলাম।
Anybody else? Is there any standard formula of computing the value of theta? I am not getting any answer, so I am keeping this question for your homework. Just think over it. Is there any standard formula? If it is possible, you please address this question to my next class. Okay. Now I am continuing. From this result, sometimes you can find the direct value of theta, but sometimes it is not possible to find the direct value of theta. So if possible, I am trying to ask, if possible, what would be the value of theta? Okay, please try to address the question in the next class. Okay, now what we are doing over here, sometimes even if you find the value of theta, the standard technique would be just put the value of theta in this expression, and you will ultimately be able to convert everything in terms of x square y square only. Some term would not, the term containing xy would not appear because of this kind of formulation, because we removed the coefficient of xy. Got it? But there is another easy technique that we are going to follow over here. That is the technique of invariant that I discussed earlier. The invariant says that a plus b must be is equal to a prime plus b prime. Now before transformation and after transformation, before transformation, this 17 is equal to small a and minus 7 is equal to small b, and after transformation, that means after using after rotation, this becomes the coefficient of a and this becomes the coefficient of b. So this 17 plus minus 7, that should be is equal to a plus b. Okay, this 17 plus minus 7, that should be is equal to a plus b. So we are applying this result over here. This a plus b is equal to 17 minus 7 is equal to 10. Okay, and secondly, let me show you another result, just a rough work. So what we have, little bit of rough work, that a plus b is equal to 17 plus of minus 7, that gives us 10. Fine. And in this expression, ab minus h square, a is equal to 17, b is equal to minus 7, and what is h? H is equal to 9 over here. So ab minus h square, that means 17 into minus 7 minus 9 square, that is equal to ab minus h square, should be is equal to this a into b minus, no term is there containing x into y, therefore h should be is equal to 0, because this expression, you see, this expression a x square Yeah, or you can write x prime.
Sir,
Yes.
sir, theta equals to tan inverse 1 by 3.
না, একটু ভালো করে চিন্তা করে তারপরে বলো। হুম। Twice h x prime y prime. So if this is the expression is equal to 1, this can be written in this way. This can be written in this way: ax square plus by prime square plus 2 into 0 into x prime y prime. That means over here the coefficient of xy is equal to 0. That means h is equal to 0 over here. That's why this ab minus h square can be written as a into b minus 0 square. Got my point? ব্যাপারটা বোঝা গেল? One is the result a plus b is equal to small a plus small b, that is equal to 10. That is one result. Another is small a into small b minus small h square, that should be is equal to ab minus, in place of h we will have 0 because no term is there containing x prime and y prime. Okay. দেখো এটা ক্লিয়ার হলো তোমাদের কাছে?
Yes, sir.
Yes, sir.
Okay, so now over here they have directly written these two results, that a plus b is equal to 10, fine, no problem is there. And secondly ab is equal to this 17 into minus 7 minus 9 square. So that I was trying to show over here, that is equal to ab is equal to this expression. Okay. And ultimately it becomes is equal to minus 200 by computation. By calculator you can find that this becomes is equal to minus 200. So we actually have two equations. One is a plus b is equal to 10 and another is equal to ab is equal to minus 200. And so from these two results you can find a minus b whole square, and that would be a plus b whole square minus 4ab is equal to 900, and therefore a minus b should be is equal to plus minus 30. And if you consider the positive sign, you will have the one result: a plus b is equal to 10 and a minus b is equal to 30. Okay. So you can solve and find the values. Again, if you consider the negative sign, that means a minus b is equal to minus 30, then again you can solve a plus b is equal to 10 and a minus b is equal to minus 30. So you can again solve these two results. I am trying to show you this result. That means over here what we have, we finally have this kind of result, that ab is equal to basically minus 200. So I'm not going through that exact computation that has been shown in this book. I'm trying to show you in my way. We can write a is equal to say minus 200 divided by b. Okay. And then we can put the result over here: a plus b is equal to 7. So a plus b, a plus, in place of a plus b is equal to 10. I'm just putting a is equal to minus 200 by b. So what we get, minus 200 by b plus b is equal to how much? 10. So this would be is equal to b square. If I make any mistake, please rectify me. Okay. B square minus 200 is equal to 10 into b. This means that b square minus 10b minus 200 is equal to 0, and that can be factorized probably in this way: b minus 20 into b plus 10 is equal to 0. Okay, again I am saying, if I make a mistake, please rectify me. Then this gives that b is equal to 20, another value is equal to minus 10, and subsequently if b is equal to 20, a becomes is equal to how much? If b is equal to 20, a becomes is equal to minus 10, and if b becomes is equal to minus 10, you would get a is equal to 20. Okay, so we actually have two set of values. One solution is that a is equal to minus 10 comma b is equal to 20, that is one set, and another set is that a is equal to 20 and b is equal to minus 10. So in your question you are given that a is a positive quantity, so you have to consider the second solution, not the first solution. Got it? In the question it is already given that a is positive. You are given that a is a positive quantity. That's why you have to choose a is equal to 20 and b is equal to minus 10, this set of solution. But if no question, no information is provided, then you will have to consider both of these two possible solutions. Even this first solution has to be considered. Anyway, so ultimately you see that a is equal to 20 and b is equal to minus 10. So we got this result. Result is proved. Okay. So that is the note over here, that in order to remove xy term, the axis had to be rotated. Even more generally, to remove any second degree term, as example x square or y square or xy, the axis had to be rotated. In that case, you will have to apply the rotation formula. Now, is it clear to you, everybody? That was
Yes, sir.
my discussion today. This much I wanted to discuss. Hmm? So this first chapter, the transformation coordinate, is finished from my part. Hmm? Many such examples have already been solved in your book, and even this in this PDF file you will find few examples in from the exercise of this book. Okay, I have solved some of these examples for you. So you please go through these examples and the solved questions and that has been given in your book, and try to finish this chapter as early as possible. This is a basic chapter. Hmm. And if you have any problem, please report me in the next class. Okay. So today even some rough work has also been done over here. Hopefully that may be helpful for you. These questions have been solved in a rough fashion, some of these questions. So hopefully this much would be sufficient for you. Got it? So if you have any question, you can ask me. Do you have any question regarding this lecture? Let me stop the recording now.